In this session, we're going to talk about RDS and the various components of RDS. This will be a three-part session, so we encourage you to take a look through each one and familiarize yourself with what is one of the key technologies MSPs use to bring their customers to Azure through the use of virtual desktops. Enjoy the sessions.
Today, we are going to spend quite a bit of time talking about RDS collections and how all of that integrates with Azure scale sets, what scale sets are, how they work, and then how Nerdio makes use of scale sets for the purposes of RDS collections. And then we'll spend a few minutes at the end talking about the new Windows Virtual Desktop and the new architecture that comes with that product and how things are going to be changing relative to the RDS deployment. Okay, so let's get started. So, again, to bring up this diagram here, we talked about all the infrastructure roles, which is the control plane and the connection broker setting, where it's responsible for authenticating users and determining how to actually land that connection, right? So once the user clicks connect, types in their password, and then gets to their desktop, the entire process where all of these roles are involved in actually making that desktop connection. Once the user is connected to the desktop, there is a client device that is connecting through to a specific virtual machine that is running Windows Server, let's say 2016 or 2019 or whatever version it may have, with desktop experience that makes it looks like Windows 10. And the user is working on that desktop, which is a specific multi-user session on a Windows server that has the RDS session host role installed on it, okay? So all of those other roles really only come in to land that connection, and some of them continue working to keep that connection, up and running. But all of the processing and all of the applications run inside of a session that's running on top of a session host. So the session host is really sort of a very critical component, a non-optional mandatory component of the entire system. And it is typically CPU bound, meaning that the resource that runs out first on a session host is the CPU, because users run their applications, things like Office and Outlook and browsers and things like that. All of those things are CPU intensive, and occasionally they're RAM bound as well. It just depends on the application workload. Sometimes the CPU may look okay, but the RAM may get exhausted and be the constraint. But typically, in my experience, it's been the CPU. Okay, so that is the RDS session host. So we talked how you can assign users on a one-to-one basis to a session host. It simplifies the deployment. It gives users more native Windows experience, but it does have some drawbacks about lack of scale out capability, lack of redundancy, and just some things around availability for that user's desktop. If maintenance needs to be done, that session host needs to be taken down, and then the users who are assigned to it no longer have a desktop to connect to. So to solve that, we spoke about the concept of RDS collections. RDS collections is a term within the RDS nomenclature and RDS deployment architecture. And an RDS collection is something you generally would open up the Remote Desktop Services Management Console as part of the Server Manager tool in Windows. You would then create a new collection. And when you create a new collection, you select whether it's a collection of virtual desktops, published desktops, or it's a collection of remote apps, which is obviously just for applications. You would select who that collection is published to by either user or particular group. And then you would add member servers into that collection. You would basically select existing servers that have already been provisioned, that have the RDS session host role enabled on them. You would, or maybe it enables it as part of the process, but you have to select existing servers into the collection configuration, and then the wizard runs, it puts them all into kind of this one group, and then it makes the RD connection broker aware that there is this collection, let's call it collection A. It has X number of members, let's call it 5. They're all supposed to be serving a particular group of users that this collection is published to, right? So the important point here is that it's a manual process that you do with existing VMs, existing hosts. So you have to build a VM, install Windows, obviously, enable all the necessary configuration, make it be identical to your other hosts in that group, right? Because if you have 5 session hosts and all of them are different, then every time the user logs in, their experience may or may not be the same depending on which host they get placed on. So it's important that the hosts are identical, that they're maintained, such as patches and all of that kind of stuff needs to be done on all of them. They're not sort of getting generated automatically. They are, manual, full, regular VMs that are joined into a collection, and that's made available to end users. Okay, so switching gears for a minute, again, let's forget about RDS for a second, and let's talk about this thing called virtual machine scale sets in Azure. Okay, so virtual machine scale sets is a service in Azure that allows you to take virtual machines, as the name implies, and put them together into a set. And then this set is a dynamically growing and shrinking set of VMs, right? So let's click the add button and see what kind of configuration is involved with the scale set. So, you obviously give it a name. You then select either a library image from Azure, like a particular VM, or you can actually select, a custom image if you want it as well. Like if you had a custom image, you can use that. You select your subscription, your resource group, your physical location, availability zone if that applies. You pre-configure a username and password that is going to be set up as the administrator on this newly provisioned set of VMs. You select how many instances is going to be your maximum, right? So in our case, let's say 5. You select the instance size. So this is where you would select a DS1 or a DS4 or whatever the case may be, right? So you can select any size right here. You then select if you want to use managed disks or not. You can set how big the disks are going to be, etc. And you can enable auto scaling. And if you enable auto scaling, then you can set up parameters of what is going to be the minimum number of VMs, the maximum number of VMs, at what point the scale set is going to scaling out. Scaling out means at what threshold of CPU consumption across all of the VMs in this host will it start increasing capacity. And you can have it increase capacity in increments of 1, 2, or 3, or whatever the number is, right? So you can say, once I'm reaching 75% CPU utilization, add 3 more VMs into my scale set. And what that's going to do is going to clone from a particular image, set them to be this size, and add them into the scale set. And then on the way in, for the scale inside, you have a threshold where if the CPU drops below a certain level, then you can start scaling in. And here is your number of VMs, sort of your step size. It's a set of 1. You can then configure networking and a few other configurations. So the concept here, as you can see, is very useful for applications that simply can be stateless, meaning you can have 1 VM or 100 VMs that are both added into a group, and they are kind of identical, not kind of, they are identical because they're based on the very same image. And then those VMs are serving some sort of a connection. So think of web servers. So you have a database, let's say Azure SQL, and you have a web server that is running, let's say, a Linux version of one of their web servers, whatever, Tomcat or Apache or whatever, what have you. And then as your traffic goes up on your website, you want to scale out and add additional web servers, and you have a load balancer in front of it. And then every new user that comes in will now be placed on another VM, which is not yet loaded. And then as all of them start getting to be highly utilized, then the next one gets added, and the next one gets added, etc. And as the demand dies down, then they start scaling in. Again, so the key here is that this is designed for stateless type connections, because the VMs can be added and removed on demand in response to CPU utilization. Okay, so that's the concept around scale sets. Really great idea. You have an application or something that's stateless, and you want to respond in real time to the demand based on CPU utilization. You tell it what that threshold is. You tell it how quickly you want it to grow. You tell it the maximum you want it to grow to, so you're not exposed to growing too large and spending a lot of money. And then you tell it how quickly you want to scale back in when the demand drops, and it does all of that for you. And if you think about sort of how people envision the cloud and they talk about the cloud, this is really kind of the main or the core functionality of what people envision cloud to be. And that is, it's a flexible, dynamic environment that responds to real-time demand and is able to flex in and out based on what a particular application or workload requires, right? It's sort of the promise of the cloud. The challenge is there's lots of limitations to the use cases where this works. And as I mentioned a few times already, it's really meant for fairly stateless connections where you are not consistently connected to a particular instance within the scale set. Each one is sort of sacrificial. It can go away at any time. A new one can be added at any time. So your application needs to not have that reliance on any particular instance of the scale set. Kind of an obvious example is you cannot have any data stored on those instances because it can disappear at any time. So your data must be offloaded, and it's really only for compute and RAM that these instances are for. Okay, so now if you think about the concept of RDS collections that we talked about, and you think about the concept of scale sets, we wanted to figure out a way how to marry those two concepts and deliver the flexibility and the dynamic nature of scale sets, but do so with RDS collections. Okay, but as I said at the beginning of the session, RDS collections is not something that's out of the box response to demand in any way. It's something that you pre-configure all the hosts, you then click, you add them into a collection, you publish that collection, and then any changes you need to make, that's a manual thing. You have to go create a new VM, go into the configuration for RDS, add that as a member into a collection, etc. So the two technologies aren't integrated or aren't even meant to be necessarily integrated in any way, especially because RDS is as stateful as it gets, right? A user is logged into a VM or into their desktop, and that desktop lives on a specific session host. And if that session host goes away, that connection and that user state during that session is gone, right? It's not like you can transfer that state to another machine. So scale sets are stateless or meant to be stateless. RDS connections are very stateful. Those two concepts don't work natively together. So we had to, go through quite a bit of engineering in order to marry those two concepts. And what we've achieved is sort of the best of both worlds. We are now using RDS collections with scale sets, and this is something that's unique to Nerdio, where it's leveraging the basic foundational functionality of Azure scale sets, but instead of using library images, it uses a template that you as the administrator select. So let me just show you in the UI what that looks like. So you go in, you say add an RDS collection. It tells me, okay, well, which host that already exists, RDS H01 or O2, do you want to use as your starting place, as your starting template? So let's say you select RDS H01. It's then going to clone that VM, make it completely independent, create an image from it. It is then going to create a scale set based on that image. It will then create an RDS collection that is going to contain the number of members that you specify for the RDS collection. We'll look at that in a minute. And then it will respond to CPU demand on the collection by adding an additional VM from this image that we just created. We call it the template, from this template. And it's going to run all the necessary commands in the Windows side to join it to the domain, to configure anything that needs to be configured on it, and then add it into the RDS collection. So that when a user goes in and connects to the connection broker, there's now more members in the RDS collection because the NAP orchestrated that whole process. Okay, so to add a collection, it's really kind of trivial. You select your session host. You can even decide if you have any on-ramp regions. You can place it in an on-ramp region. You give it a description, and it creates a new collection for you. Now, once the collection is created, here are a few things you can do. You can click on Manage Autoscale, and the first thing up here is it shows you the template. So this is where I can configure the size of the typical or of the session host inside of that collection, and that sort of corresponds to this instance size setting. So it knows that whenever it builds a new member of this collection, it's going to be based on this size that I specify. I can also specify how big of a disk and what disk type. So I can make this be a premium, a standard, SSD, HDD, whatever size I want it to be. That could be customized as well. I then set the boundaries. These will be familiar: minimum number, maximum number, and then the number of hosts that are in standby. Okay, so what this means, and this is not native to scale sets, but the way scale sets work is every time the CPU threshold is crossed, it starts adding a new instance, and that instance basically starts out fresh. It has to build it from image, boot it up, join it to the domain, do everything it needs to do. And when it scales in, it basically takes it out of the domain, removes it from the scale set, removes it from the RDS collection, and then destroys that VM. The process of doing that for a Linux machine is pretty quick because you don't have to join things to domain and do sysprep and stuff. But doing it for Windows is quite long. It takes up to 15 minutes to scale out, meaning add a new host. So we have a feature in the NAP that allows you to set up a number of standby hosts. And what will happen if I send, let's say, this to 5 and this to 1, so my collection will start out with one host, and as CPU starts going up, it's going to add a second one, a third one, a fourth one, a fifth one, until it can now not go past 5, or until the CPU utilization stabilizes. Then when it starts scaling in, it's going to first shut a server off instead of deleting it. And by shutting it off, it makes it available so that when it needs to scale out again, instead of building it from scratch, it can just power a server back on, which takes a couple of minutes rather than the 15 minutes to build a new one. So the number I put in here, if I put in, let's say 2, then it's going to shut the first 2 down. And then when it's time to scale in by the third one, it's going to shut one more down and then delete the oldest one or something of that nature. Okay, so that is the boundaries, the minimum, maximum, and standby. The scaling logic should be pretty self-explanatory, right? We looked at the CPU threshold. We've also added a duration. So it's not that I want this CPU threshold to be crossed for a second. Let's say all the VMs all of a sudden start running an update or something that triggers the CPU to go high. I don't want the system to start scaling me out right away. I want to make sure that this demand on CPU is actually true and persistent. So you say, let's say for 10 minutes, if it stays above that level, then I want you to add a new host. And it's going to keep doing that until either it reaches the maximum or until the CPU utilization across all of the hosts on average drops below 65%. And then to scale in, we set another threshold, let's call it 40% for 20 minutes. So then if it drops for 40%, below 40% for 20 minutes or more, it's going to start scaling in. And we've also added an additional setting that it's not going to start scaling in until it's after business hours. So you could specify to do it at any time, but for an RDS use case, you can imagine you don't want the users to be disconnected during the day. So you basically say, okay, don't start scaling in until 6 p.m. And at 6 p.m., find the host with the fewest number of active users and delete that one first, right? So it's not the last one that was provisioned and it's not the first one that was provisioned. It's the one that has the least amount of users on it. And then the third setting is to send a message to the users logged into a particular host 10 minutes before it's going to be removed, telling them something is going to happen, that they need to log off and log back on. And when they do that, they're going to actually, even if they do it as soon as they get the message, even before the host goes away, because the host is going to be placed in what's called drain mode, where it's not accepting new connections. If a user disconnects and reconnects or logs off and logs back on, they will be placed on another host because the one that's going to be scaled in is going to be in drain mode, not accepting new connections. Okay, so these are the auto scale settings. There's a template size, there is boundaries, there is triggers, and then some cutoff points during time, and then there is notifications to, not just pull things from the users without them expecting for that to happen. Okay, the next thing I want to show you is this Manage Collections screen. So when you click on Manage Collections, you have a couple of things that may look familiar. This is, again, the template. And here you get a little more granular control. You can actually see the name of the VM. You can see its IP address. You can rename the template. You can also change its configuration, just like we saw on the Autoscale page. And you can see when was the last time that the template was updated, right? So this template was updated on September 14th. What you can do is you can power it on, and once it's powered on, the state will obviously change. You'll be able to RDP into it, or connect to it whatever way you connect to it, make any changes, and then come back here and shut it down. When you do that, it's going to update the image that's going to be based on this template so that the collection, now nothing is running, no users are ever connecting to the template. The template is just a way to configure these non-persistent hosts, and you'll see they have kind of these weird names attached to them, and these are kind of sequential or sometimes they're random. You can see that they're all different, but the template serves as the image for those. So you can come back here and shut it down and set it as template, and then the next step would be updating your hosts to reflect any of the changes that were made. So a few things to note. So you see here the template date and the date of all of these three hosts that are in the system is the same, which means that all of them are up to date. Now, let's say you make a change. They're not going to change automatically. What will happen is as they scale in and scale out, the new servers that get added will be based on the new template date, but any ones that exist are not going to be based on the new template date. So you have a few things you can do. You can either do update hosts from here, which is going to update all of the hosts that may not be up to date yet, right? And it's going to reboot them and rebuild them. So it's a kind of disruptive operation. Or what you can do is you can place a certain host in drain mode, let's say deactivated, which means it cannot take any more connections. You can then reboot it to make sure nobody is actually connected to it. And then you can update it. You can send a message to the users on it to say, hey, I'm going to be taking this down. And then you can update it, which is going to bring it up to the latest version of the template. You can do that one host at a time if you wanted to. And then the final option, which is kind of similar to this update host, is if you go to the collection page right here, you can update hosts from here as well. Okay, so it tells me all of them are up to date in this particular case. Okay, then there are a few other things you can do with the individual hosts. Remember, once these are running, they're just regular VMs. So you can generate an RDP file and log into them, Maybe you want to shadow a user, maybe you want to test something out. There's no guarantee that this server will exist tomorrow, but currently it's a VM that you can manage. You can also deactivate it, as I mentioned, which puts it in drain mode. It makes this yellow, this icon yellow, and doesn't allow any new sessions, but any existing sessions will still work. Update, send message we looked at. You can reboot, shut it down, or delete it. If you delete the host, you cannot violate your minimum auto scale setting. So if let's say you have a minimum setting of 2 and you have 2 hosts inside, you cannot delete any one of them because that's going to violate those settings. Or you can actually add a host manually. So let's say the CPU threshold hasn't been crossed to warrant a new host, but you're expecting users to start logging in any moment and you want to get ahead of that. So if you have a standby host, you can just come in and power it on. Or if you don't have a standby host and you want to add new capacity, as long as it doesn't violate your maximum setting, you can just click add host, and that will add a host into this collection. You can also delete a host. I think I mentioned that. If you delete a host and then all of a sudden the CPU utilization spikes up on the one remaining one, it's going to automatically build one. When it builds one, you can see that there are logs that say, okay, start RDS collection, host by autoscale. So they started one, then it added one. So you can see all of these actions are happening in response to actual demand, CPU demand on these servers. You can also see the CPU that's over the last 30 minutes on a particular host. Like this one has 2%, this one has 0%. And you can see how many users are assigned or logged into a particular host. So if I go back to the collection, this is a nice summary view. It shows me my template size. It shows me the state of that collection. So I have one or more RDS session hosts that are unavailable because some of them are in drain mode. Then I can see what my auto scale settings are, my boundaries, my triggers, and my cutoff time for business hours. I can see how many there are total, how many are standby, how many users there are. And if I click on users, it's actually going to show me the current state of any connected session. So if anyone is connected or disconnected or logged in, I will see it here, and then I can click on the user, and you all know that under the users management module, I can reset the RDS session. So if a user, let's say, is locked up, I can just come in here, find them from the list, and then reset their RDS session so they get logged off and they can log into and have a fresh session. And then this average CPU we already looked at. Now, if we look at the Azure side of things, okay, so here are the two scale sets corresponding to the two RDS collections. So let's click on one of them and see what it looks like inside. So if we see inside of this thing, again, we'll notice some metrics and some statistics. And if we look at instances, you will see that there are there are instances in here that correspond. So this is collection A. Let's look at collection A. We have 3 hosts. We have one that's on but deactivated, meaning it's in drain mode, and one that's off. So if we look here, we have, both of these are on. Azure doesn't know that it's in drain mode from an RDS perspective. And Azure also knows that they are in the latest model, meaning they have the latest image that they've been based on, and one is stopped because that's a standby host. If we look at scaling, you'll notice those same parameters. We have an instance count. Nope, sorry, that's not where that works. You have various sizes that are set that basically correspond. So, this is controlling this.